Hot on the heels of Python 3.14 is the first public alpha release of Python 3.15. And right now, you can try out one of the biggest new features in 3.15, the sampling profiler. Python has long had built-in tools for profiling code, the profile and cProfile modules. But they're cumbersome to use because you have to either decorate your code with calls to the profiler, what's called instrumenting your code, or you have to run the entire program in the context of the profiler. And either way, you run into another big drawback of using these modules. Profiling your code adds enormous overhead to its runtime. It's intrusive. Now, over the last several years, a number of third parties have developed new profiling tools for Python that use statistical sampling techniques. Austin, for instance, is one of them. Instead of tracing absolutely every call that's made, they trace a subset of them, a randomly chosen sample, so they're far less intrusive, but they're still informative. With Python 3.15, we now have a new statistical sampling profiling module built in, and it's called simply profiling. It makes use of new hooks in Python to instrument code from within the interpreter, so you don't need to make any changes at all to your Python code to use it. You run your program in one process, and you capture its profile information with another process. Let's take a look at how this works. This contrived example I have here does not do anything useful, but it'll be a good way to illustrate what we're going to do. It just generates some random numbers into a list, sorts the list, and prints the results, and it does this over and over again. It also gives us, at the start of the program, a process ID, which we will need to run the sampling profiler. To invoke the sampling profiler on this process, we use this command in another terminal, py-3.15-m profiling.sampling -p for process, and then the process ID. We could also pass in the name of a module or file to execute that directly, but I want to use the process ID method to show how we can use this to profile something already running, especially if it's a long-running process like a server that's already been deployed. So let's start our program in earnest, and now let's invoke the sampling profiler. Now by default, it samples the running process for 10 seconds at a rate of 10,000 samples per second. We can ramp up the sampling frequency a good deal more than that if we need to, and we can sample for a longer period of time if we need to, but the defaults tend to be just fine to get a good snapshot of how things are. So once the profiler finishes running, it'll spit out a report into the console of the top lines of code and functions that were represented in the sampling. As you can see, the line that's taking up the vast majority of our time here is line 9, and that's the print function. If you didn't know printing lots and lots of things to the console was a massive drain on performance, here's your evidence. In fact, the print is such an overrepresented part of the statistics for this that we can't get more useful information about what else our program might be spending its time on. So that's our first optimization hint. Let's get rid of this print statement. Now let's run the program again with print toggled off and capture some more statistics from it. Incidentally, the breakdown of the stats that we capture is something that we can also configure enormously, but again, for what we're doing here, the default settings are going to give us plenty to work with. Now, thanks to the print statement being gone, we can get a far better idea of what our program is actually spending its time doing. So the most amount of time is spent in the program at line 7. That's the creation of the list. And the random number generation portion of that is what takes up most of the time in it, rather than the list creation per se. The sort operation, line 8, is only about 12% of our total time. So our biggest wins would come from optimizing how our random numbers are generated. And again, that would depend on what we really wanted to achieve here, but at least it gives us a good idea of where things stand. Now, if we scroll down, we can see some more useful statistics broken out by the profiler, and they give us some good sense of what else might need optimizing. The hotspots described here, these are areas in the code where the program spends most of its time without making calls to other things. And this can be a really useful insight if you have a hot loop, as we do here, and we want to get a sense of which function calls run most often over your entire program. So optimizing those tend to be the best place to start. The highest call frequency is a little different. This is a measure of what functions get called most often, regardless of how much time is spent inside them. Every function call that you make, in pretty much every language, has some overhead. So if you're making lots of calls to something that don't take up that much time internally, the mere act of making those calls is still going to add up. So this is another useful index to pay attention to. And then we have highest call magnification. This is an index of how many other function calls get made from within any one function call. For this one program, things aren't too bad. We have at most 2.5 times as many calls from one of our functions. The number varies depending on the run. If we had one function that invoked, say, 1,000 other calls, that might be something to investigate, but it would all depend on how much any of those calls constituted an actual bottleneck or a significant portion of the program's total runtime. Now, I've barely scratched the surface on how to get useful results out of the sampling profiler, but this, along with the new debugging tools introduced in Python 3.14, which I covered in an earlier video, they're fast shaping up to be some of the most useful built-in utilities for Python. And in future videos, I'm going to show some more advanced and focused use of the sampling profiler to help you unsnarl the bottlenecks in your Python apps with minimal intrusion. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and InfoWorld.com.